Good morning friends. After the discussion of the graph of binding energy per nucleon versus atomic mass number. Now we know that the small central region of the atom in which the most of the mass of the atom and entire positive charge of the atom is concentrated. This small central region is known as the nucleus of an atom. Okay. Inside the atom, the positively charged proton and chargeless neutron are present. We know that the Coulombian force of attraction or the repulsion, that means the electrical force exerted between the charged particle. So inside the nucleus, positive charged proton are present and chargeless neutron are present. Therefore, the repulsion force between the proton exerted inside the nucleus. In spite of this type of the repulsion force exerted between the proton in a nucleus, why? The proton and neutron are combined together inside the nucleus, that means in small central region of an atom. So question is that. So this type of the discussion is carried out in nuclear forces, right? So question is that explain the nuclear force and write its characteristics. So sometimes there is asked for the 2 marks question, write notes on nuclear forces or the nuclear force, right? So the nucleus is the central part of the atom. In nucleus, the positively charged proton and chargeless neutron are present. Already we know it. Already we discussed in chapter atom and also in the beginning of this chapter nucleus. Okay. The Coulomb repulsion force between the proton act for small distance and also for large distance. In the small region, like the nucleus. That means inside the nucleus, the proton and neutron are present. Proton is positive charge. Therefore, the repulsion force between the proton act for all distances, either small or large distance. Right? Okay. So it shows that the some other attractive force between the nucleons in the nucleus must be prevailing, which should be large enough to overcome the effect of the Coulomb repulsion force and hold them together. So the question arises in our mind that why the repulsion force act between the proton, why the proton are tightly bound or living inside the nucleus. So here it shows that the sum force of attractive or the attractive force between the nucleons in the nucleus must be prevailing, which should be large enough to overcome the repulsion force and hold them together. There is the nucleus. Inside the nucleus, proton, chargeless neutron are present. So between the proton at small distance and large distance, the repulsion force act between them. So the question is that why the proton and neutron are hold together in the nucleus. So it shows that the sum attractive force between the nucleus in the nucleus is prevailing, which should be large to overcome the Coulomb repulsion force and hold them together. So some force of attraction must be exerted between the proton, neutron and neutron, which overcame the repulsion force. And as a result, neutron and proton are held together inside the nucleus. In a nucleus, the force acting between the two protons, two neutron and proton-neutron, that is known as the nuclear force. This force of attraction between two protons, two neutrons and proton-neutron is known as the nuclear force. And this force is the short-range force. And this force is not depends on the charge, that is the independent of the charge. Therefore, the proton and neutron commonly known as the nucleon. Again, this force is independent of the charge of the particle. Right? Therefore, the proton and neutron is commonly known as the nucleons. Clear? Again, the nucleus is the central part of the atom in which the positively charged proton and chargeless neutron are present. Right? The Coulomb repulsion force between the proton act for all distances, small and large. However, they are held tightly together in the small region like nucleus. So here the force of repulsion act between the two protons. So why? The proton and neutron are tightly combined together in small central region, that means inside the nucleus. So it shows that the some attractive force between the nucleons in the nucleus must be prevailing, which overcame the effect of the Coulomb repulsion force and held them together. So some force of attraction exerted must be exerted, which overcame the effect of the repulsion force and tightly bound the proton and neutron inside the nucleus. In a nucleus, the force act between the two protons to neutrons and neutron-proton, that is known as the nuclear force, and this force is type of attractive force, and this force is short-range force. For this force, there is no difference between the proton and neutron. That means this nuclear force is independent of charge of the particle. And as a result, the proton and neutron is commonly known as the nucleon. Right? Now, what are the features of the nuclear forces? The first is that the nuclear force is much stronger than the Coulombian force of repulsion between the two charges. Again, the nuclear force is much stronger than the Coulomb force acting between the charges, or the gravitational force between the masses. So this nuclear force is much stronger than the Coulombian force and also gravitational force between the masses. That's why it holds the proton and neutron in the nucleus. So that is the reason why the proton and neutron are held inside the nucleus. Because the nuclear force is much stronger than the Coulombian force and also the gravitational force between the masses. So as a result, the protons and neutrons are held inside the nucleus. Second characteristic is that the nuclear force between the two nucleons falls rapidly to zero as their distance is more than the few femtometers. As the distance between the two proton or the proton neutron or the neutron neutron is increased more than the some few femtometer. So this nuclear force is rapidly becomes the zero. Rapidly becomes zero. This leads to the situation of the forces in middle or the large size nucleus. So this fact leads to the situation of the forces in middle and also the large size nucleus, and which is the reason for the constancy of the binding energy per nucleon. Already we discussed in the graph the binding energy of the nucleus for the middle range nuclei is almost constant. Again, the second characteristic is that the nuclear force between the two nucleons falls rapidly zero as their distance is more than few femtometers. This leads to the situation of the forces in middle and large size nuclei. Right? and which leads to which is the result of the constant of the binding energy per nucleon. Clear? It means the potential energy is minimum at distance R0 is about 0.8 FM. Is about 0.8 FM. That means the femtometer. This means that the force is effective for the distance larger than 0.8 FM. Here the force, nuclear force is effective force if the distance between the proton, neutron, and proton is more than 0.8 FM. And this nuclear force is repulsion force if the distance is less than 0.8 FM. Keep in mind these sentences for MCQ type question. The nuclear force is effective if the distance is more than 0.8 FM, and the repulsion force, nuclear force is repulsive if the distance is less than the 0.8 FM. 0.8 FM. Clear? Okay. Now the third point is the nuclear force between the proton, neutron, and proton are same. There is no difference between the particles or between the proton and neutron. Thus, the nuclear force does not depend on the electric charge. This nuclear force is independent of the charge of the particle or the independent of the electric charge. Therefore, there is no difference between the proton and neutron. This force of attraction is exerted between either proton or neutron or proton and neutron. That is the independent of the charge, and due to that reason, the proton and neutron commonly known as the nucleon. Right? So again, the three characteristics of nuclear forces. One is the nuclear force is much stronger than the Coulomb force, acting between the charges. And it is also the stronger than the gravitational force between the masses. Right? Second is the nuclear force between the two charges or the two nucleons falls rapidly to zero as the distance is increases than the few femtometer. And third is that the nuclear force is independent of the electric charge. Here the nuclear force between the proton, neutron, and proton are same. There is no difference between the proton and neutron for this nuclear force. Therefore, proton and neutron are commonly known as the nucleon. Clear? So that is the nuclear. After the discussion of the nuclear forces, now the next question is that define radioactivity and explain it. Right? Now, the phenomena of radiation emission from a compound is known as the radioactivity. It means what? Now, the heavy nuclei. In heavy nuclei, the proton and neutron inside the nucleus are more. Right? Therefore, the most of the heavy nuclei are unstable form. To get the stability, they radiate the energy either in form of alpha particle, that means the helium nucleus, or in form of beta particles, that means in form of electron or positron, and the some compound or the some nuclei radiate the energy or the energy in form of photon, that means the gamma nuclei, and try to attain the stability. Right? So, during this type of the stability, that means the heavy nuclei transfer from unstable to the stable state. The energy are radiated either in form of particle or in form of radiation, that means in form of energy or photon. Right? So this phenomena is known as the radioactivity. Again, the phenomena of radiation, that means the emission from a compound, is known as the radioactivity. The question is that define the radioactivity and explain it. Again, the definition is that the phenomena of radiation emission from a compound is known as the radioactivity. The emitted radiation, that is known as the radioactive radiation. What are the radiation is emitted by the compound is known as the radioactive radiation, and element contains in the compound is known as the radioactive element. What are the compounds? Radiate the radiation, that is known as the radioactive compound or the radioactive element. But the compound contains the element that is known as the radioactive element. Again, the emitted radiation, that is known as the radioactive radiation, and the element or the compound emits the radiation is known as the radioactive element or the radioactive compound. Now, the main points of the radioactivity. Important points of radioactivity. What is the point? The emission of radioactive radiation is spontaneous and continuous. Again, the emission of radioactive radiation is spontaneous and continuous. It is not affected by the external factors like the change in temperature, pressure, right? Presence of electric and magnetic field. And such parameters cannot stop the emission of radioactive radiation or cannot change the rate of emission. So what it says that the important points of radioactivity. First is the emission of the radioactive radiation is spontaneous and continuous. It is not affected by the external parameter like as the change in temperature, change in pressure, the presence of electric field, presence of magnetic field. So this type of the parameter cannot change the rate of radiation or cannot stop the radiation. Right? Such parameter cannot stop the emission of radiation or cannot change the rate of emission. Again, what is the radioactivity? The phenomena of radiation emission from a compound is known as the radioactivity. The emitted radiation is known as the radioactive radiation, and the elements contained in compound is known as radioactive element. After that, the important points of radioactivity. The emission of radioactive radiation is spontaneous and continuous. So as we open the radioactive element, on the spot it starts the emission of radioactive radiation. And also there is a continuous, not after emitting it takes some time for the another emission. So there is the continuous and also the spontaneous emission. Okay, now it is not affected by the external parameter. That means the radiation is not affected by the external parameters or the external factors like as the change in temperature, change in pressure, presence of electric field or the presence of magnetic field. So electric field, magnetic field, temperature, pressure does not change or does not stop, cannot stop the emission or the radiation. Right? Such parameters cannot stop the emission of radioactivity, radiation, or cannot change the rate of emission. So no any factor can change or cannot stop the radiation. Okay. Now, one possibility is that even by chemically combine a radioactive element with any other element, the rate of emission of radiation is not affected. As we combine the radioactive element with the other element chemically, so there is no change in rate of emission of radiation. Right? That means the rate of emission of radiation is not affected as we combine the radioactive element with any element. But cannot stop the radiation. So physical parameter, temperature, pressure, presence of electric field and magnetic field cannot change the rate of emission or cannot stop the emission. Same way, the chemical parameter like as we chemically combine the radioactive element with the other element, the rate of radiation is not affected or not changed. These 2 points show that the radioactivity is nuclear phenomenon, in which the nuclei of the heavy elements are unstable and during their attempts to acquire the stability, they emit the radioactive radiation. Again, these 2 points, the physical parameter and chemical, shows that the radioactivity is the nuclear phenomenon, in which the nuclei of the heavy elements are unstable and during their attempts to acquire the stability, they emit the radioactive radiation. Generally, the most of the heavy nuclei or the heavy elements are unstable and during their attempts to acquire the stability, they emit the radioactive radiation. And this radioactive radiation is the nuclear phenomenon. Here, during this radioactive radiation, 3 types of the radioactive decay occurs in nature. When the heavy nuclei are decayed, at that time, the 3 types of the radioactive decay take place in nature, which are: first is the alpha decay, second is the beta decay, and third is the gamma decay. When the heavy nuclei are initially in unstable state and try to attain the stability, they emit the radioactive radiation. During this radioactive radiation, the 3 types of the decay occurs in nature. The first is the alpha decay. During the alpha decay, in which the helium nucleus 2He4 is emitted. 2He4 is emitted. Suppose, for example, one element is X, having the atomic number is Z and atomic mass number is A. That is known as the paired atom. That is known as the paired element. This paired element is decayed. That means the alpha decay takes place and the daughter element is formed. The daughter element has the atomic number is decreased by 2 and atomic mass number is decreased by 4. Therefore, the helium nucleus, that means the alpha particle, is emitted in this radioactive radiation. Again, when the heavy nucleus is in unstable state, trying to attain the stability, they emit the radioactive radiation and the 3 types of the radiation decay take place. Radioactive decay take place in nature. First is the alpha decay. During the alpha decay, the helium nucleus 2He4 is emitted. For example, the element XZA decayed by emitting the alpha particles. So SZA, that is known as the paired element, and new formally element, that is known as the daughter element. And the helium nucleus is formed. Right? So that is known as the alpha decay. So SZA convert into YZ minus 2A minus 4 plus 2He4. Helium nucleus, that means the alpha decay takes place. Second radioactive decay is the beta decay. That is the beta decay, in which the electrons or the position. What is the position? Actually, the position is the antiparticle of the electron. Now, the particle with the same mass as electron, but with a charge exactly opposite to that of the electron. the positron, electron is denoted by E minus, positron is denoted by E plus. Positron is antiparticle of electron. Positron is antiparticle of electron. Again, during the beta decay, in which the electrons are the positron. What is the positron? Positron is the particle with the same mass as electron, but with a charge exactly opposite to the electron, are emitted. Now here the base element Za convert to the neutral element Z minus 1a. At that time the electron is emitted. Minus E 0. Minus 1 is 0. Here the beta negative emission take place, that means the beta minus decay. And the second process, when the positron is emitted, at that time the band element XZA convert into the YZ plus 1 plus 1 is 0, that means the beta plus emission take place, that means the positron is emitted. Positron is emitted. During the beta decay, the atomic number of the neutral element is either decreased by 1 or increased by 1. As the electron is emitted, the atomic number is decreased by 1. That is the increase by 1. And when the positron is emitted, at the time the atomic number is decreased by 1. When the electron is emitted, the atomic number is increased by 1. There is no change in atomic mass number during the beta decay. Only the change occurs in the atomic number. As the electron is emitted, the atomic number of the neutral element is increased by 1. And as the positron is emitted, the atomic number of neutral element is decreased by 1. And third decay is the gamma decay. During the gamma decay, in which the high energy, that means the hundreds of kilo electron volt or more, the photons are emitted. Now here, during the gamma decay, the photons with the more energy are emitted, like that with XZA converted into the YZA plus gamma. Here the gamma emission takes place. Gamma is not a particle, therefore the atomic mass and atomic number and atomic mass of the neutral element does not change. Only the energy in terms of the kilo electron volt or the mega electron volt are emitted. Clear? Okay. So in radioactive decay, the three types of the decay occurs in nature. One is the alpha decay, second is beta decay, and third is the gamma decay. In alpha decay, the atomic number of neutral element is decreased by 2 and atomic mass number is also decreased by 4. Because the alpha particle, that means the helium nucleus, are newly formed. During the beta decay, here the two types of the beta decay take place, beta negative and beta positive. During the beta negative, the electrons are emitted with the neutral element. So during the electron emitted or the beta emission, beta minus emission, the atomic number of the neutral element is increased by 1. And during the positron emitted, the atomic number of neutral element is decreased by 1. There is no change in atomic mass number. A does not change. Okay. Now during the gamma decay, the atomic number and atomic mass does not change. Only the energy is emitted. We also discuss about the alpha, beta, and gamma decay in detail after the exponential law of radioactive decay. Right.